Hi everybody, welcome to the second lab of the cloud computing course. My name is Alex Palesandro and today we will talk about containers. So first of all, for this lab we have to spawn two VMs here. We have to spawn a client VM and a Docker VM from the VM that you have available here. So it's pretty easy, the usual client VM, and this time we will have to spawn the Docker VM. Okay. So let's start. We have two parts in this lab. The first one is more focused on namespaces and C groups and all about what we can do to isolate and to constrain the execution of a certain application. So the idea is that here, when we talk about containers, we talk about application that can be executed with a certain amount of isolation and that cannot consume all the resources of your system. So you can constrain the execution of the application in terms of consumption of resources. So in this exercise we will have to deal with Linux namespaces which are useful to isolate the application execution, and C groups which are useful to constrain the usage of resources, for example CPU, by the applications. Okay, so let's start by connecting to the Docker VM that we have to complete the exercise. I think the first part is really agnostic to the system that you are using, in the sense that it will use only the facilities provided by the Linux kernel, but maybe you have to install some tools, so it's better to connect to the second VM. So SSH, MATLAB, 16. Okay. Okay, so we have changed our, we have already connected to that VM, so we have to, if this happens, it's no problem, you are already using a VM that had been recreated with the same IP. It's normal. It can happen because if you keep the same client VM for several iterations. Okay, so we are inside this VM. We are inside Docker. Let's start with the first exercise. So the first exercise is not about the namespaces. We start with an enabling technology which is chroot. So I will show you how this exercise works, and then we can I let the rest for you for the lab. So the idea is we create a directory where we want to recreate our system. So the idea of chroot is, okay, we want to separate the execution of an application from the other one, from the rest of the system, which is one of the first things that you can think if you want to separate this execution, is to say, okay, let's start to execute the application, and we want to avoid that the application is able to modify, to read, to see all the files present in the system outside a certain scope. So what we can do is to create the chroot. To do so, to create an environment, to copy all the files that these application require to work, and then launch it and see that it cannot go outside, it cannot escape from this kind of jail we created. So okay, we created the directory. Now we will create the first command. Will create the bin directory, and then we will try to execute a shell inside this environment. So we can copy this shell. Okay, verbose will, it's copied, and then we have to copy all the libraries of the application, because otherwise we will not able to start this application, and normally we will not have to pay attention to libraries that are used by bin bash. But in this way, since we are isolating the execution of this application, we have to copy it in the rest of the system. So we have this script that will do the work for you. We can have a look more in detail. So we are paying for all library that is in this grep, so we are grepping only a certain part of the LDD command. We will see in a few how LDD lists the libraries, and then we can copy all those libraries into the path inside the chroot directory. Okay, so we did so. It deserves to have a look to this. So let's copy it. So this will print for us the libraries. Okay. Sorry, I have some troubles. Okay. And then we can. What we have to do is to purge this part, so keep only the complete path. So what we are doing in this script is to list all the libraries and then cut the output to keep only that part. But yeah, it's pretty simple. And then we have to change root. So we have copied all the libraries. What we want to do is to change root. So we will use our user as user to change root inside, and we will launch bin bash in the context of the directory we just created. And it works. So we have a bash. We cannot do a lot of stuff, so we have no the commands, because this bash has no access to those commands. But what's important to know is that we are in a different environment. So if you want to access the file outside, we cannot do so. If we try to print all the file that we have here, we will see that we have just the file that we just copied. So the libraries that we just copied, the bin bash, and so on. So yeah, it's pretty straightforward, but pretty effective. And then we can go outside, and we are done. So this is the first exercise, and the rest of the exercise will show you that you can also copy a file inside this context, and you have access to this content. So if we go inside Docker Lab chroot, you will see that you are able to see your files inside the chroot. So the chroot is isolated for the application which are executing inside, but they are not for the rest of the system. So this is pretty important to know. Okay, so now we have some exercises like that about Linux namespaces. We focus on three main kind of namespaces: process ID, mount, and network namespaces. The first one, process ID, is about the ID of your process. So the idea is that you have to you can isolate the process ID your application is getting without letting the application itself to know which is its real process ID. So you will create this namespace, and the application will get a one ID, and all the child of this process will get following IDs, but they are uncorrelated to the IDs that they get in the system-wide process ID. So this is useful because this way you cannot able to see other applications executing in the system. You are only constrained to your context, and this is useful. This is pretty useful when you are in a system where you are a lot of applications out of process and processes, and you want to show them only what they concern their execution in a way that they cannot try to disrupt the execution of other application or snoop what is going on the rest of the system. So those features are pretty easily available when we talk about VMs. Here, when we talk about containers, other application, we have to enforce those isolation one by another to construct the abstraction of containers. So here we are looking at all the different pieces, some of those at least, to create this container abstraction that at the end of the day will be similar to what we have in virtual machines. So we have no visibility from outside, we have not the possibility to, we have a network namespace completely separated, and we cannot have the same, we have this different route from the rest of the system. So this is pretty much what we want to go, but without having the performance overhead that we had in virtualization. In virtualization with the full virtualization with VMs. Okay, so we have another couple of exercises about namespaces here, and it is about the mount namespaces. So the capacity to copy and to share parts of the subtree of the file system, so the mount points across different processes. Even here we will see how we can create different mount namespaces and different process namespaces by using the command unshare, which allows you to differentiate the child application, child process that is created in your shell from the rest of the system, from the context of your shell, of your bash application. Yeah. So this is quite interesting because it is massively used and it corresponds to a Linux system call to do so. Okay, we have also an exercise about network. This network is the network namespaces. The network namespaces are really interesting because it allows you to create separated environments for networking, and you can have your own set of IP, your own set of interfaces, your firewall rules, your routing table, everything you need. And the idea is that you can create them really simply, for example with this command, and you can add the interfaces, execute command in those namespaces. It's pretty easy to use. And what is also interesting is that in this exercise you can create the same topology that we created in the first lab, where we had to create 3 VMs and connect them and use one VM as a router. Here we will do the same stuff but with network namespaces, and it's interesting because you can also here measure the performance of this topology and see if it is faster than VMs or not. Yeah, so this is the exercise that you would hold the commands that will allow you to do so. And then you have Linux C groups, which is more concerning another aspect of containers. So with namespaces and chroot, you are definitely looking for isolating the execution of your processes, of your applications. Now you are trying to constrain the amount of resources that you are able to give to those applications, so the application are able to consume. And this is interesting because with C groups you can easily limit them and set a threshold and see with multiple processes how the system will behave if you set, for example, a threshold to the 25% of your CPU. So it's pretty interesting because it's adopted everywhere to constrain the execution of application. Okay, so cleaning up the lab. Okay, this is clear, and then we have to move to the third part, the second part of this laboratory, which is about Docker. So let's talk about Docker in the next video. I think this is it for this one. Feel free to ask for more details if something is not clear, and have a nice lab.